On an average day, a homing pigeon can travel 60 miles per hour and fly up to 100 miles in a straight line. But if it gets lost or released far away from home, how does it get back? The answer might surprise you because it doesn't rely on landmarks or memorized routes like we might expect. Instead, it uses something called a magnetic map. When you're driving somewhere unfamiliar and you want to make sure you don't get lost, you might use GPS. It relies on signals from satellites orbiting the Earth to tell you where you are and where you need to turn next. But pigeons don't have access to modern technology. So when they're young, they memorize the positions of certain landmarks relative to their nest, and they can remember that information for years. For example, a young pigeon released far away from home will first try to retrace its steps. If that doesn't work, it'll fly until it finds a landmark it recognizes. Then it'll use what it remembers about the direction of home relative to that landmark to get closer. And then once it finds another landmark, it'll repeat the process until it gets home. Basically, they're using a mental map to triangulate their position. But that is not the whole story, because experiments show that pigeons do need landmarks to get home if they've ever trained well. For example, in one experiment, a pigeon was released 438 miles away from its home loft. It flew almost directly there, traveling over hills and valleys, avoiding obstacles like trees and buildings and cars, and made it home within 2 hours. That's impressive navigation for any species, really. And it is not the only long-distance navigator that uses a kind of map to keep track of where it has been and where it needs to go. In fact, scientists think many animals, including birds, turtles, bees, and even ants, use magnetic maps to navigate. But how do they do it? Well, a lot of research suggests that these animals use Earth's magnetic field as a compass and a map. Animals that navigate using the sun or stars as reference points need a clear view of the sky. But Earth's magnetic field is always there, whether it's sunny or cloudy, which makes it a reliable way to orient yourself. When you walk next to each other, you might unconsciously mimic the other person's movements, even if you don't realize it. And it turns out that the magnetic field has an effect on all animals in a given area. So they all move in the same direction, which means it is possible to compare your own magnetic map with the magnetic maps of others to figure out where you are relative to them. But how exactly do they sense the magnetic field? Scientists don't know for sure, but some have hypothesized that it has to do with proteins. The proteins could be sensing changes in the magnetic field that cause electric signals to move through the body. Or they could be absorbing light that's slightly polarized by the magnetic field, allowing the animal to see magnetic field lines, like a smattering of stars. But regardless of how they sense the magnetic field, scientists think it works together with other sensory information, like visual cues from the landscape, to build a map in their brains. It's still early in this research, but if it pans out, it could help us understand how all sorts of animals find their way home, as well as help develop better ways of tracking animals and perhaps even better compasses for humans. And speaking of getting lost, sometimes we get lost in the world of online shopping. It happens to the best of us. But thanks for watching.